Hello children, welcome to Zero Panic Maths. In today's session, let us continue our discussion on arithmetic progressions and finding the nth term of an arithmetic progression. So before you start watching today's session, I suggest you to please watch the introduction video on chapter 5 arithmetic progression, wherein we have studied what is an arithmetic progression is, and what is the first term is, and how to find out the common difference. All that knowledge will help you in better understanding the concept of the nth term of an arithmetic progression. Okay, so let us continue our discussion today. So how to find the nth term of an arithmetic progression as a real life example of an arithmetic progression in the beginning of this chapter. Okay, the example was Reena has been offered a job with a starting monthly salary of 8,000. See, it is a starting monthly salary 8,000. So in first year her salary will be 8,000 per month. Okay, with an annual increment of rupees 500. Okay, rupees 500 annual increment she will get every year. Okay, so for the second year 500 will be added to 8,000 and 8,500 will be her salary in second year. Okay, third year obviously 500 will be added again to 8,500 and it will become 9,000, 9,500, like that it goes on continuing. Okay, so her salary in the first, second and third year is given here. Okay, and that will be respectively these values, and you can guess the next value, and the number goes on. For every year's salary 500 is added at the end of the year, and next year's salary, total salary, will be calculated. Okay, now if this is the situation, what would be the salary for the fifth year? How do you calculate the salary for the fifth year with the given knowledge? Okay, we know that we are going to add 500 to the previous year to get the salary of the next year. Assume that we only have that knowledge only to get the salary of the next year. So with that, how do you find out the salary for the fifth year? Is for the first year. Okay, say for example first year salary, as it is already given. Okay, first year salary is equal to 8,000, right? First year is 8,000 because that is given. It is a starting monthly salary is 8,000. Okay, now how do you find out the second year salary? How do you find out the second year salary? Is by adding 8,000 and 500 to it, right? So that will be 8,500, right? 8,500, let it be. Okay, now again for the third year, what do you do is you add another 5,000, 8,000 plus 5,000 plus 5,000, 500, not 5,000, it is 500 increment. So 500 you added twice. So can I write this as 8,000 plus 2 times 500? Is it fine? For the third year we are adding 2 times the increment, because first year 8,000, second year 1 increment, third year 1 increment. So at the beginning of the third year it will be 2 times 500. So that 2 can I write like this: 8,000 is third year, that is 2 is 3 minus 1 into 500. Is it fine if I write like this? Okay, because 3, that we consider it as a n value. Okay, third year. For second year also you can write a plus d. A plus d is actually 2 minus 1 into the difference or the increment here. Okay, now similarly if I consider it for fourth year, okay, consider it for fourth year, what will be the salary for fourth year? It is 8,000 plus 3 times the increment value. Is it fine? Okay, 3 times the increment value is going to be added for the fourth year. So that can be again written as 8,000 plus 3 times 500. and 3 can be written it as 8,000 plus 4 minus 1 into 500. Now why am I writing 4 minus 1 again? Because to represent it is fourth year. Assuming that it is nth year, it will be n minus 1 for me. Okay, that is the reason. Okay, now let us calculate the same for fifth year. I'm moving to the next year. Okay, so next slide. Okay, so this is continuation of that. So what we want is fifth year salary. Okay, now how do I calculate for fifth year? Fifth year is again so fifth year salary I can write, listen to me carefully, fifth year salary is equal to 8,000, that is the salary of the first year, and similarly 4 times I'll be writing. Okay, assume 4 times I will be adding the increment value, right? So 4 can I write like this, 8,000 plus 4 is 5 minus 1 into D, and this is the increment value that is fixed. This is also fixed, this is also fixed, and this varies based on which year's salary you are going to get. Okay, now this is the salary. So total salary, how much it will be? 8,000 plus 5 minus 1 is 4, and this is 500, that is 500 into 4, 2000. So total salary will be 10,000 at the end of, sorry, at the beginning of fifth year. That is what we got. Okay, now assume that if it is asked for 15 year, are you going to continue the same procedure for 15 year? Because for 15 year you have to add 500 14 times, right? That is 15 minus 1 times. Okay, and then multiply that value, add it to the beginning salary, that will get you the 15-year salary. So that can I do directly like this. So for 15th year salary, it is the salary of the first year. Okay, and as see, if it is fifth year, we are seeing 5 minus 1. Previously if you see, for the fourth year 4 minus 1, for the third year 3 minus 1, like that we were doing, right? So similarly, can I do for 15th year, it is 15 minus 1 into the increment. Can I do this? Okay, so that is 8,000 plus 15 minus 1, that is 4 14 14 5 it is 70. Okay, that is 7,000 then. Okay, 7,000 plus 8,000, that is 15,000 at the end of 15 years, right? Is it fine? 15,000 at the end of the beginning of the 15 year is the salary, that according to the given knowledge of the first year salary and the increment we have calculated. So remember this and concentrate on this. So what all we have done is, this is the salary of the first year, this is the year for which we are calculating the salary, and this is the increment. Okay, can we write like that? Okay, this is, suppose this is starting salary, this is starting salary, or first term, starting salary, or that is the first term, this is the value of n. Okay, and this is the common difference. Is it right? Common difference, or it is the increment in this case. So with all this information, having the 8,000 value as starting salary, and n can be considered as the year for which you are calculating the salary, and this as the common difference, which actually represents the increment in this case. With all this knowledge, can we derive a generic formula to calculate the salary for any year? Okay, so in general, okay, remember all these steps. In general, what we can form, what we can derive is, assume that, in general, assume that first term is a1. Okay, and a1 is a is always first term. Okay, and in our case, what is a here is 8,000. A here is 8,000 in our case. Okay, in the second term, assume second term is a2. Okay, and how do we derive a2? How do we calculate a2? Is by adding a difference, the common difference d to the first term, that is a1 plus d, that is a1 is a, so a plus d. So in our case, what is this? 8000 is a and 500 is our d, common difference d. Okay, now continuing in this way, the third term a3 is common difference added to the previous term. Previous term is a2. Okay, and what is a2? A2 is a plus d. A2 is a plus d. Okay, and a plus d plus another d. This d is this, and this is a2. This is a2. Okay, so what it comes to? A plus 2d. So 2, I am writing it as 3 minus 1 just to represent this nth term. This is third term, so 3 minus 1. For fourth term, continuously, if you continue in this way, for fourth term it will be 4 minus 1. For fifth term it will be 5 minus 1. So in general, if you continue the same pattern, the nth term of the arithmetic progression, nth term in general, will you represent this 1 2 3 4 5 by n, a positive integer, n by a positive integer, then in general this will be the formula for calculating the nth term of an arithmetic progression. What is that nth term represented by? Is an. So if it is 10th term, it will be a10. If it is 20th term, it will be a20. And in which case n is the number that represents for which you have to find the term. Okay, and a is, what is the a is the first term of an arithmetic progression, always the very first term. And what is d is the common difference. So it's a simple formula to remember: a plus n minus 1 multiplied by d. So that will always give you the nth term of a arithmetic progression. Okay, let us use this knowledge to solve some of the problems and find out the nth term, or given nth term, find out the number of terms, all that different kind of problems we have to see. Okay, let us see the example 3. Okay, so what is the problem here? Find the 10th term. Okay, so what is n here? N is 10. Okay, we are here. What is a according to the given series or the arithmetic progression? A is the first term. First term is always the value that appears in the beginning of the list. And what is d? D, since they have already given it as arithmetic progression, we can find out the difference between second and 1, and that is the common difference. Okay, 7 minus 2. And what is common difference? D is 5, right? And what is n they have given? What is n? N is 10, because they want us to find out the 10th term. So n is 10 in this case. Okay, now let us write this once. Okay, later on we will not write this, but you have to remember this formula. Okay, so this is the formula to calculate the 10th term or nth term in general. Therefore a10, that is the 10th term. A10 is a. What is a? A is 2. Okay, and what is n? N is 10 minus 1. And what is d? D is 5, right? So 2 plus, what is 10 minus 1? 9. 9 5s are 45, right? And 45 plus 2, that is 47. That is a10. Therefore the 10th term, finally you can write 10th term is equal to 47. Simple solution for the problem. Okay, move to the next problem. So the next problem here is, which term of the arithmetic progression, this is the arithmetic progression, and they asked which term of this arithmetic progression will be minus 81. Here, see, you observe here, it is not always you are going to find out the nth term. Okay, using that formula, a plus n minus 1 into d, you might be asked to find out the value of n, value of a, value of d, and even the value of a n also. Okay, so any of the three given values, the fourth one you should be able to find out. Okay, so that is what it is asked here. They have given an value and we are asked to find out the n value. So which term is n in our case. Okay, which term of this AP is minus 81. Okay, also there is a second part of this problem. Also, is any term 0? Give reasons for your answer. So there are two parts of this problem. Okay, let us find out where what term minus 81 will be for this arithmetic progression. Okay, listen to me carefully. Okay, so here, okay, what is all given? A as the first term. So what is the first term? 21. Okay, A is first term. What is common difference? D is always the difference between the first and the the second and the first. Okay, 18 minus 21, that is minus 3. And what is 81? We need to consider here. Minus 81 is actually an. Okay, we don't know what is n. That is what we are going to find out, because which term of AP they are asking. You understood this, right? Okay, now let us put all these values and find out n. Okay, so uh, we can say, so what is n? We can write this way. Okay, so an, what is our formula? Is an is a plus n minus 1 into d. Okay, let us keep this formula in your mind. And an, what is an? Is minus 81. And what is a? Is 21, right? Plus n we don't know, and keep that n as it is, and minus 3, right? Now let us multiply minus 3 to n and minus 1, okay, to get the next values of that. Keep 21 as it is, and minus 3 into n will be minus 3n. Minus 3 into minus 1 will be plus 3. Okay, so 21 plus 3 is 24. Let me actually transfer this minus 3n to the left side. That will actually get me plus 3n. Okay, I don't have to write the plus here. Plus 3n, and it is 21 plus 3, that is 24. And this minus 81 also I'll be transferring on the right side. Okay, so what it will be? It is 105, right? 105 3n. So what is n? N is equal to 105 divided by 3, right? So 3 3s and 3 5s, it is 35. So therefore, n is equal to 35. So what does it mean? If it is n is equal to 35, it's very simple, that 35th term of this AP is minus 81. That is our first part. They asked which term of this AP is minus 81, right? So I can say, so 35th term, 35th term of this AP, you can write that is equal to minus 81. That is first part. Now the second part, they have asked that is any term 0? It means whether there is a 0 that comes inside this uh, arithmetic progression, because the 3 every time 3 is getting reduced from the previous number, right? So if you go in this way, is there any term n or any term nth wherein you will get the value as 0? So again, the same way we need to find out the n value. Okay, and but in that case the difference is minus 81 is now 0 in this case. An, considering an as 0, we need to find out n. Okay, let us see that. Okay, now the second part is let an be, an is equal to 0. To find out this, okay, to find the what you can say, to find out the 0 as a term, 0 as a term. Let me consider this. Okay, an is equal to 0. To find out 0 as a term, okay, let me put the value of that. 0 is equal to, now an is equal to, again the same value of a, b, you are going to consider and going to find out n. And n, remember, that should be a positive integer. If you get a positive integer, then only you will say that okay, that is the position of 0 in this arithmetic progression. Okay, let us see that. What is a? A is 21 plus n minus 1, and what is d is minus 3. Okay, so 0 is equal to, again, as it is there in the previous term here, okay, 21 minus 3n, it is minus 3 into n and plus 3, right? Okay, 21 plus 3 is equal to 24, and take minus 3n to the left side, it will be 3n is equal to 24. So what is n then? N is equal to 24 by 3, right? N is equal to 8 in this case. So since we got n is equal to a positive integer, then we can say that therefore eighth term of the given AP is 0, you can say. Eighth term of the given AP is 0. Okay, that is how we need to understand and solve the problem. Okay, hope you understood this. Okay, there are two parts of this. Okay, let us move to the next problem. Okay, determine the AP whose third term is 5 and seventh term is 9. Okay, now this is something interesting. Okay, you see that they have given third term is 5 and seventh term is 9. Here in this problem they have not given the value of the first term a or difference, nothing they have given. Okay, we have to find out what is the first term and what is the common difference, because we have to determine the whole arithmetic progression only, starting from first term, second term, third term, at least 3-4 terms we need to write. Okay, so if you get the first term and the common difference, you can write the whole arithmetic progression, right? Okay, now what is given here? What is given here? Listen carefully. Okay, third term is a3, right? Third term is a3. So what is a3? A3 is equal to 5. And what else is given? Seventh term, that is a7, and a7 is 9, right? Okay, now how do we write a3? A3 according to the an formula, an is equal to a plus n minus 1 into d. So a3 is a plus 3 minus 1 into d, that is a plus 2d, right? So can I write a3 is equal to a plus 2d is equal to 5? Can I write this way? Yes, we can write. Similarly, a7 is 6d. A plus 6d is equal to 9. So this is the third term, this is the seventh term, and according to the information, it is equal to 5, it is equal to 9. Okay, considering this as equation 1 and this as equation 2, what can you do with this? Okay, are you getting something like the quadratic equations with two variables? Okay, quadratic equations with two variables a and d. Can we subtract equation 1 from equation 2 to get any of these values cancelled, and we can get the value of another? Okay, so that only we need to do and find out a and d. Okay, see, this problem in arithmetic progression is actually depending on the quadratic equations chapter that we have studied previously. Okay, so let us subtract equation 1 from equation 2. Okay, or else I can say equation 2 minus equation 1. Equation 2 minus equation 1. So what it will give me is a plus 6d minus a minus 2d, right, is equal to 9 minus 5. left side minus I'm doing, and remember this carefully, since it is plus here, and it'll make the whole thing minus, will make both the terms minus. Okay, remember this, you should not be doing anything mistake here. Okay, don't keep minus only to a and keep plus to 2d, it will not be in that way. Okay, so plus a minus a will get cancelled here, and 6d minus 2d will be 4d, and it is 9 minus 5, it is 4d. So what is d in this case? D is equal to 1. So the common difference is d, what we got. Okay, now what we need to determine the whole arithmetic progression, we got common difference, we need the first term. Can we get the first term by putting d value in any of these two equations? We can easily get that. Okay, so substitute what you should say is substitute d in equation 1, right? Equation 1, and what you are going to get is a is equal to 5 minus 2d, 5 minus 2d. So the 2d I'm taking to the right side. So what is this? 5 minus 2 into 1, what is that? D is 1, so 5 minus 2, so a is equal to 3. So the first term as 3 and common difference as 1. Can we write the arithmetic progression? Can we write the arithmetic progression? So the required AP, you can write it very easily, that a required arithmetic progression is a plus d, a plus 2d, a plus 3d, that way. Okay, a is equal to 3, a plus d is our second term, or you can say a1 is equal to a plus d, and a1 is equal to a2 is equal to a plus d, that is 3 plus 1, that is 4. Okay, and a3 is equal to a plus 2d, and what is a plus 2d, that is 4 plus 1, or else it should be calculated based on the first term and that this one, right? A plus 2, that is 5, and that is already given here. See, third term is 5, so third term 5. Okay, and fourth term a plus 3d, and is equal to 3 plus 3, right? That is 6. So it is 3, 4, 5, 6, and so on. And seventh term will be 9 also in this case. Okay, so this is what the solution for this problem. You understood this? Huh? Is it interesting? Okay, let us see some more examples. uh, Again, the problem here is to find out n only. Okay, what they are saying is check whether this 301 comes in this list. If you go on increasing the values with a constant difference, with a fixed difference in this arithmetic progression, at some point at nth position, some nth position, are you going to get 301? Okay, that is what the problem here is. Okay, now how do we decide that whether we are going to get 301 in this case or not? We have to find out that n value which might contain 301 if you continue this arithmetic progression in the same way with the same difference. If you get a n value, remember, if you get n value as a positive integer, then only you should say that 301 comes in this list, otherwise no. Here what is a is equal to 5, a is equal to 5 as it is given here, and what is d, common difference is 11 minus 5, and which is equal to 6. Okay, see, 6 is getting added to every previous number. Okay, and what is a n they have given? An is 30. Now let me write an. What is an? An is 301. What is a? A plus n minus 1 into d. What is d? Is 6 for us. Correct? Okay. Let us extend this. Okay. 5 plus 6n minus 6. 6n minus 6. So it is 6n. 5 minus 6 is minus 1. Take minus 1 to this side. It will become 301 plus 1 is equal to 6n. Just switch the values from left to right and right to left. It will be 6n is equal to 302, right? So what is n? N is equal to 302 divided by 6. Whether 6 fully divides 302, 6 ones are 6 5s are 30, but 2 remains, it cannot. So whether 3, so it cannot directly divide. It means you can just divide and keep some fraction. Okay, so 2 3s are, and 2 ones are 2, 2 5s are, and 2 ones are 2. So it is 151 by 3. N is equal to 151 by 3. So n is not a positive integer, it is a rational number. Okay, so therefore since you can write, since n is not a positive integer, n is not a positive integer, okay, 301 is not a term of the given list. Okay, you can write 301 is not a term in the given list. In the given, you can say given AP, given arithmetic progression. You understood this? Let us move quickly to the next problem. Okay, now you see how many 2-digit numbers are divisible by 3. You see, again you need to form the arithmetic progression first based on the given information. Find out the first term, common difference, and then find out n. Again you are asked to find out n value here. Okay, but what are the values, or what are the terms of the arithmetic progression? That is what you should be deriving first from the given problem. Okay, so how many 2-digit numbers are divisible by 5? 2-digit numbers, what are the 2-digit numbers? Need to find out what are the numbers that are divisible by 3 between 10 and 99. Okay, okay, so whether 10, let us first derive the arithmetic progression. Okay, let the required AP is, okay, is, you can say, is the list divisible by 3, right? It is a list divisible by 3, or you can say the numbers divisible by 3, anything it can be. Okay, so whether 10 divisible by 3, fully divisible? No. 11? No. Let us consider 12. Yes. Okay, so 12 is divisible by 3. Among the 2-digit numbers, the first number that is divisible by 3 is 12. What is the next number? 15. Go on adding 3 to it. Go on adding 3 to it. 18, 21. So if you continue in this way with a difference of 3 till 99, so 99 is also divisible by 3, right? Till 99 you're going to get numbers. Now what is our problem is, what is our problem? How many 2-digit numbers? So what is this list? Now we got the list, we need to find out how many terms will appear from 12 to 99 with a difference of 3, or the multiples of 3. That is what the problem, actual problem is. You understood this point? Okay, now let us find out what is A, D and N. What is A here? Is 12. A is 12. What is D? Obviously it is 3, because all these are multiples of 3. You can say 15 minus 12, that is 3 only. Okay, and what is AN? AN is the last term always. AN is the last term or the nth term. Okay, here we know what is the last term, so we are writing AN is equal to 99, but we don't know what is the value of n for which we'll get 99. Let us see what is AN. AN is 99, and A, what is A? Sorry, A we can write it as 12 plus, as it is n minus 1, we know we don't know the value of n, and it is 3. 3 is the difference. Okay, common difference. 12 plus, as it is 12 plus 3n minus 3, right? 3n minus 3. So 12 minus 3, it will be 9, okay? Plus 9, and take plus 9 to the left hand side, okay? I can write it as 99 minus 9 is equal to 3n, right? So switch the values, 3n to the left side, and 99 minus 9, it is 90. And what is n then? N is equal to 90 minus 3, it is 30. So what is the value of n? 30. And what is n we considered in this problem is how many total terms exist in this given arithmetic progression. So therefore you can say that, so 30 are the numbers, or what you can write totally. So totally 30 numbers are divisible by 3. Totally 30 numbers are divisible by 3, because that is what is asked, right? Divisible by how many numbers are divisible by 3, they are asking. So totally 30 numbers are divisible by 3. And what are those 30 numbers? 12, 15, 18, 21 till 99. 32 is a two-digit number. Okay, remember this is 30. You should write it here, 32-digit numbers. Sorry, I forgot this. It is 32-digit numbers, okay, are divisible by 3. This is what the solution to this problem. Okay, let us quickly move to the next problem. Okay, now what is the next problem? Find the 11th term from the last term. Okay, this is very important. From the last term, there is an arithmetic progression given, and from last term you have to find out the 11th term. Okay, it is not from the first. Okay, find the 11th term from the last term towards the first term. So it means in the reverse way. Okay, so here it is given as first term as 10, minus 3 is the common difference here. So 3 is getting reduced, and finally we have the an value as minus 62. Minus 62. So what they are asking is find the 11th term from the last. Okay. So we have to find out how many terms are there, totally how many terms are there, so that we can come uh, backward from the last term till the 11th term. Okay, so let us first find, you can write first find the value of n, the value of n with the given AP. Okay, so what is a here? What is a? Is 10, right? And what is d? D is the second term minus the first term. And what is this? It is minus 3. Remember, it is not 3, it is minus 3. Okay, because by adding minus 3 to the previous term, you are getting the very next term. And what is an in this case? An is minus 62. Okay, with this given information, you need to find out how many terms are there. So based on that, you can decide what will be the 11th term from the last, right? Okay, let us find it out. Minus 62, that is an. Okay, an is equal to a plus, that is 10 plus n minus 1 into minus 3 again, right? Okay, so this will be 10 plus minus, sorry, minus 3 into n, that is minus 3n, and minus 3 into minus 1, that is plus 3. It will be 10 plus 3, 13. Okay, keep 13 here only. I'll keep 13 here only and take minus 3 to this side. It will become 3n, and take minus 62 to that side. That will be plus 62. And what it will be? 65 and 75. So n is equal to 75 divided by 3. Therefore, what is n? Is 25. N is 25, right? So it means that there are totally 25 terms are there in that arithmetic progression. So if there are 25, listen carefully, if there are 25 terms, we are asked to find out the 11th term from the last 25th term. Okay, 25th term will be the first term in that case. In that case, this will be the first term, 24th term will be the second term, okay, 23 will be the third term. So in that way, if you come, then 15th term in the 25 series list of numbers, 15th term from the last will be the 11th term. Okay, you understood? Therefore you can write, if there are 25, if there are 25 terms, 15th term 15th term will be 11th term. 15th term will be 11th from last. 11th from last. You can write it in short. Okay. 15th term will be 15th term will be the 11th term from the last. That is what we want. So with this given information, if you find A15, that will be your 11th term from the last. Okay, let us do that. Okay, so therefore, so it is A15. We need to find out A15. So n is equal to 15 in this case. What is A? Substitute the same value of A. A is 10. And n, we are given with n, that is 15. And what is D? It is minus 3. D is minus 3 only. Okay, we need to find out A15. And what is A15? It is 10 and 42. And what is A15 in this case? Then it is minus 32. A15 which is 11th term from the last. Okay, this is how you find the 11th term from the last. Okay, now there is an alternate way to resolve this. Okay, now you understood this, there's no confusion. Let us see an alternate way which will be little bit more easier than this, but you need to make little bit of adjustments to do that. Okay, now what is an alternate way to get this? Okay, now listen to me carefully. Since they have asked 11th term from the last term towards the first term, so if you just reverse the given arithmetic progression, then reverse it. Okay, first reverse it. We will see, reverse the AP. What you are going to get is minus 62 as the first number, minus 62 as the first number, but the next number is not by adding minus 3, but it is plus 3, because you are going to get the greater number, or sorry, the lesser number compared to 62 in terms of minus. Okay, so it will be plus 3, it will be plus 3, so that is minus 58. Okay, not 58, 3, it is 59. So in this way, if you continue, the last term will be 10 in this case. Okay, so in this case, it means that A is equal to, you understood this clearly? We are actually reversing the arithmetic progression so that you can directly find out the 11th term somewhere here. If you get the 11th term directly, you can get it. You don't have to find the total number of n and then find out from 25th to 15th is the 11th. You don't have to do all that, because you are just reversing the arithmetic progression. The overall 11th term is the 11th term that what you need. Okay, but in this case, the terms, the first term, the difference will be different. Okay, so what is A? A is minus 62. And what is D? D, as I already told, it is plus 3, not minus 3. Okay, okay, now, and what we need to find out is the an, and what is n in this case is 11, because 11th term is what we want. Okay, see, it will be very easy. Okay, now let us find out A11 in this case. What is A? A is 62. And what is n? N is 11. 11 minus 1. Okay, into 3. That is, what is this? 11 minus 1, 10. 10 into 3, 30. Okay, and minus 62 plus 30. And what is that? Minus 62 plus 30. And what is the 11th term? Is minus 32. You see it? It is the same value, minus 32. Okay. Which will be more easier? This part will be more easier. So with the given problem, if you analyze in this way, you are going to get the same value. Or if you feel that this part is easier, by reversing it and finding out the common difference in a different way, and you can directly find out A11, that will also get you the same result. I hope you understood this. Okay, now let us quickly move to the next problem. Okay, this problem is related to the simple interest. Okay, there is a sum of 1,000 rupees invested at a rate of 8% simple interest. Okay, it is a simple interest. Calculate the interest at the end of each year. So our arithmetic progression, we need to actually find out the arithmetic progressions containing the interests. Do these interests form an arithmetic progression? They are asking. We know that. Okay, what we know is simple interest is equal to P rate of interest. P is the principal here, rate of interest, R and T as the time in years. Okay, R is rate of interest for 100 rupees. Okay, now you know that. Okay, you know this formula, right? You have already studied the simple interest in class 8. Okay, now let us substitute the value of principal amount, which is 1,000 rupees, a rate of interest, which is 8. Okay, and time, 1 for first year, 2 for second year, and 3 for third year. Let us find out those three values and write the values in series and see whether it forms an AP or not. Okay, let us do that. Okay, therefore interest for first year, you can say that interest for first year, interest for first year is equal to, what is that, 1,000, okay, multiplied by 8 multiplied by 1. It is first year. 8 is the rate of interest and 1,000 is principal amount, the sum amount that what we started with. Okay, cancel two zeros and 8 tens are, it is rupees 8. Rupees 8 for first year. Similarly, interest for second year. Interest for second year, right? What is second year? Again, the principal amount remains the same, rate of interest remains the same, but the time value will change to 2. Cancel the two zeros. 8 twos are 16, tens are, it is 160. See, at the end of second year, it is 160. Similarly, third year, quickly we can do it for third year also. Okay, and what is third year value is 1,000 into 8 into the value of time will get to 3, right? So again, cancel the two zeros. 8 threes are 24, tens are is rupees 240. So it's sufficient. You got the interest for first year, second year, and third year. So therefore the interests for, you can write that interests for first, second, and third year. First, second, third year. Okay, third year makes an AP. You can say that makes an AP or represent an arithmetic progression. You can write that. And what is that? Those interests, rupees 80 for the first year, rupees 160 for the second year, 240 for the third year, and so on. Is what our arithmetic progression, right? Okay, now with this arithmetic progression, the first part is completed. Secondly, what we need is interest at the end of 30 years. So what is required? N is 30. We need to find out A30. Okay, so here you need to go for the second part. Here A is equal to 80, D is equal to also 80. D is also 80, right? Because the difference is 80, and N is equal to 30. You need to find out A30 is what the interest at the end of 30 years. Okay. So let us find out A 30 is equal to A plus, that is 80. N minus, what is N is 30 minus 1, and what is D? D is again 80. Difference is also 80. Okay, so 80 plus 29 into 80. 29 into 80. That is 2400 minus 80. You can say, because 80, 30s are 2400 minus 1. That is minus 80 in that case. So it is 2320. 2320. Okay. So 2320 plus 80 will actually make it 2400 again. A30 is equal to 2400. And what is that 2400 is? Interest at the end of 30 years. Therefore, interest for 30 years, interest for 30 years is equal to rupees 2400 is the solution for this problem. Okay. Okay, let us. So it is a flower bed. There are 23 rose plants in the first row. In the first row there are 23. 1 2 3 roses they are keeping, and in the first row they are keeping 23 roses. In the second row they are keeping 21 rows, means reducing 2. Okay, 19 rows in the third. Okay, and so on and so on. So what will be our arithmetic progression? 23 in the first row, 21 in the second row, third row 19, 2 2 they are reducing. So A is 23 and D is minus 2. Okay, so there are 5 rose plants in the last row. So last row they have given. So the value of AN they have given. There are 5 rose plants in the last row. How many rows there are in the flower bed? Okay, that is what they are asking. Now assume that this is a flower bed. Okay, and they are arranging 23 in the first. Okay, reduced to and 21 in the second, reduced to again, and it is 19, and continuing in this way. Finally 1 2 3 4 5. 5 is the, this is what the flower bed looks like. Assume that. Okay, this is what the flower bed looks like, and what they are asking us to find out is how many rows are there in this. What is this? N. For the given AP is represented by, is represented as, you can say that, the given AP is represented as 23, 21, 19, and finally 5 rows. And what we need to find out? N. Simple. Okay, so you write out that A is 23, and what is D? D is minus 2. 21 minus 3, you can write that. Okay, D is minus 2, and AN, the last term, AN, nth term they have given, last term is AN is 5, and we are asked to find out N. What is the number of rows? That makes AN is equal to 5. Okay, okay. AN is equal to A plus N minus 1 into D. Keep that in your mind. Okay, what is AN? AN is 5. What is A? A plus N minus 1 into D. What is D? Is minus 2. Okay, now multiply minus 2 to N. Okay, so keep 5 here. 23 minus 2 N, it is minus 2N, minus 2 into plus 1, that is plus 2. Okay, 23 plus 2, it is 25. Keep 25 that side and take minus 2N to the left side, it will become plus 2N. Take 5 to that side, it will become 25 minus 5. Okay, so N is equal to 20 divided by 2, right? Therefore N is equal to 10. So what is the answer? Therefore, there are 10 rows in the flower bed. Okay, 10 rows in the flower bed. This is the answer. Okay, let us see there are any problems. Okay, using the same formula we are going to resolve some of the exercise problems also. So let us start with exercise problem 5.2, that is also depending on the same formula. Okay, let us start that in the next session. Okay, thank you.